Hi, I got a question on my website to go through a question from June 2015 G484 paper. It was to go through question 1b, so I thought I'd go through question 1 as a whole, and that way I'll get that plus the rest of the question, which will hopefully be helpful. So question 1a is about, or question 1 in general is actually about the Apollo space landing. In question 1a we're shown a diagram of one of the landing modules on the surface of the moon, and it's got a couple of forces acting on it. It's got a normal reaction force there and the weight, and we're asked to explain why this statement is, or the explanation of the student is not right. So the student states that the normal contact force N is equal in magnitude to the weight W because of Newton's third law. Now we need to give two reasons in A part 1 why that's not right. So the two reasons would be, number 1, N and W are not forces of the same type. And second reason would be that N and W both act on the same object. So Newton's third law applies to forces of the same type, so to gravitational forces, to contact forces, to friction forces, and so on. It's not forces of that are different type, and they need to act on different objects. So Newton's third law says that if body A exerts a force on body B, then body B will exert an equal and opposite force on body A. So you see that one force acts on body A, one force acts on body B. So that's why it doesn't satisfy Newton's third law. Let's go down to the next bit. Use Newton's third law to state the magnitude and location of the force pairing up with the weight W. The magnitude will be equal to the weight W, so that's the first thing to say there. The location will be the other objects in the body A, body B pairing. W is acting on the lunar module. It's a gravitational force, and it's there due to the moon. The moon is exerting a gravitational force downwards on the lunar module. So that means that the lunar module is exerting an equal and opposite force on the moon upwards. So it would be a gravitational force upwards on the moon, and equal in magnitude to W. That's what I would say for that one. So upwards as opposed to downwards for that one. So that's those parts of the question. And this is 1b. This is the what I was particularly requested to go through. If I just zoom in on that one. Yeah, this is question 1b, which I was asked to go through. While the astronauts were on the surface of the moon, one of them hit a golf ball with a club, and he declared that it went for miles and miles. The ball was given an initial velocity u, and at a fixed angle of theta, showed that the horizontal distance travelled by the ball is directly proportional to u squared. So what are we going to do for this? This is an example of projectile motion. So what we've got happening is our golf ball is projected at u, which is theta to the horizontal there. Follows some trajectory covering this distance here. That's S. I'm calling that SH, so that's the horizontal distance it travels. And on the moon, there's no atmosphere, so the golf ball is travelling without any drag. I'm going to call the gravitational field strength for the moon GM. So that's going to provide an acceleration downwards on the ball. The time taken to reach here, this is going to be max height. So that's SV max. That is the time corresponding to that I'm going to call T. Because it's symmetrical, the full flight time is going to be 2T. So the time taken to go up is the same time to go down. Right, let's write some expressions down then. So the horizontal distance that it travels at SH is going to be the horizontal component of the initial velocity multiplied by the time it takes to travel there, which is 2t. UH is u cos theta. That's u cos theta times 2t. In brackets. So that means it's 2u cos theta t. Call that equation 1. So that what I've done there is dealt with the horizontal. Now let's deal with the vertical aspect of the motion. Because the ball will be decelerated by the gravitational field and then accelerated, this is a Suvat problem. Good practice is to always write down all of the quantities that you know. So this, for the full flight is, what am I doing for the full flight here? No, what I'm going to do is deal with the time to reach the top there. So I'm going to find an expression for t, and then I can substitute that into equation 1. So that's what I'm going to do. So this is going to be SV max, or you could call it h if you wanted to. The initial velocity is u sine theta. V, oh yeah, I'll call these vertical. V is 0. So when it reaches maximum height, the vertical component of the velocity is 0. So that's the time, at that instant, the velocity is about to change direction. And this is minus gm, because this acts downwards, and I've taken upwards as positive for this, so the initial velocity is positive, and t is equal to t. The equation I'll use, I'm not interested in this quantity here, SV max, don't want to know it, and I don't know what it is, so I'll use these four quantities, v, u, a and t. So I use this equation, and I'll rearrange that for t. T is v minus u over a. Now I can substitute in the values that I've got here. So I get 0 minus u sine theta over a, which is minus gm. That's actually going to be u sine theta over gm. That's equation 2. So now I've got an expression for t. Because I want to find the distance here, I can now substitute for t in this equation. So then sub t1. Then what I get is sh is equal to 2u cos theta multiplied by t, which is equal to u sine theta over gm. Now if I rearrange this, I get 2 cos theta sine theta over gm times u squared. And everything in the brackets there is constant. Cos theta is constant, sine theta is constant for a fixed angle. GM is constant, the 2 is obviously constant. So that's SH is equal to a constant times U squared. So I could say that. Hopefully this will be visible on video. So that means that SH, the horizontal distance, is directly proportional to U squared. That's the only variable there. And that's how I would answer B. I've answered it at greater length than you would have to do for an exam, but just to show everything and explain everything in full.